bottom of the page, there is a graph of y equals tan x. I will show you, if you want to draw it off to the side, how you would draw a graph of tan x. So x will be our angles, and y will equal tan of x. For the graph of tan of x, what we notice if we look on our unit circle is that at pi over 2 and 3 pi over 2, what's tan? It's undefined. So the way that we show that on our tan graph is we draw asymptotes at pi over 2. This would be pi. 3 pi over 2, there will be asymptotes. And here would be 2 pi. So if we still make from 0 to 2 pi on our positive x-axis there, at pi over 2 and 3 pi over 2, you're going to have asymptotes. If you went in the negative direction, you're going to have asymptotes at negative pi over 2 and negative 3 pi over 2 as well. And it would keep going forever. There's going to be a whole bunch of asymptotes for our tan graph. Then if we think about our other axes family, what is tan at 0 and pi? It's 0. So we know that at 0 and pi and 2 pi and negative pi, your tan graph is always going to be 0. Another value, if you would like to graph another value, half of pi over 2 here would be pi over 4. What is tan of pi over 4? 1. And tan of negative pi over 4 is negative 1. And so the tan graph looks very similar to an x cubed graph that just happens over and over and over again. That is your parent graph for your tan graph. Some properties of our tan graph are listed here. Again, I like our graph better because the grid paper that the textbook has used has more values on there that you don't need and more grid lines. All you need to show is your values that have your asymptotes and your values where they're equal to 0, which is basically your axes family again. And then know that this is the basic shape of it. So some properties of tan. Sometimes you're asked for all the equations of the asymptotes. And sometimes you're asked for the domain. The domain of tan, okay, and they haven't written in the proper form, the domain is everything except for pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Everything except for the odd multiples of pi over 2. So the way we would write the domain is x cannot equal, and you remember we had two different ways that we wrote those odd multiples of pi over 2 when we did cos. One way we could say 2k plus 1 times pi over 2, where k is an integer, because 2k plus 1 makes an odd number times pi over 2. The other way that we wrote it is start with one you can't have. You can't have pi over 2. And then what's the distance between pi over 2, 3 pi over 2? The distance between them is pi. So you can add multiples of pi where k is an integer. So there we have our domain. Our domain is everything except for the asymptotes. And you could choose one of those two ways to write it. The zeros are k pi. So this you can just highlight. Our zeros are k pi. And since there's no maximum and no minimum, the range is everything. The period of sine and cosine is 2 pi. The period of tan is just pi. The period is how long it takes to repeat itself. So if we look at our graph that we drew, can you see it's sort of like that x cubed graph over and over and over again? How long does it take for one of those x cubed graphs to repeat itself? Well, from here to here. From this asymptote to that asymptote. Yes? The periods are going to be the same until we start horizontally stretching and compressing them, which we haven't done yet. Warning, we will be doing that. The next example. So they always start. This is the starting point. You know that your period for tan starts at pi. But then we're going to stretch them and compress them. Okay, we'll show you. It's not too bad. Okay, so this is the graph of tan and the properties of tan.